Well, hello everyone, and welcome to Unit 5, Lesson 5. That's Data in Society in Unit 5. We are now into Lesson 5, which is representing numbers. As we learned in the last lesson, binary operation, AST2, was the binary operation to decode and encode words. And we use letters for coding and decoding. And now we are going to go into numbers. How do we present to the computer a way to read numbers? The way we do that is by using a special bit combination. And it's a pretty set bit because it is only one way to work it. And I will show you how that works. So let's look at the overview first. Why don't you go ahead while I'm reading you the overview, pull up the activity guide, because we'll be doing the activity guide first. The activity guide is on a separate page in there. So go ahead and pull it up from your classroom. And that's the activity guide for Unit 5, Lesson 5. Okay, in this lesson, you're going to learn about the binary number system with a set of cards. And we're not going to use the cards today. I gave you the cards on your in your classroom. If you choose to use that, you're more than welcome to. You can cut them up. And what it is it's a set of dice, and I'll show you what they look like. But we're not going to use those for what we're doing today. I find it's very simple process, and if you want to do that at home, you're more than welcome to. Okay, with the set of cards that represent the place values in a binary base 2 number system by collecting a collection of dots, you're going to learn how to turn bits on and off by turning card faces up and down. Then observe the numbers that result from the different patterns. Eventually, you're going to be able to extend the pattern into a generic 4-bit system. Okay, the purpose of this lesson is you will learn how to use binary system to represent integers. Unlike ASC2, which is presented as an arbitrary mapping of bit patterns to characters, binary numbers are introduced within the context of patterns of numbers. You're going to use the patterns to determine the binary representation of different numbers rather than simple looking at them in a table. Okay, we don't have any vocab words today. The objective of today's lesson: use a binary system to represent numbers and extend a representation system based on patterns. Okay, so if we look into code.org, and like I said, I want you to pull up your activity guide first, and we'll jump to that after I read you a couple things. First of all, the overview as we go into code.org. This lesson introduces the binary number system with a set of cards. And again, we're going to show you the cards, but we won't be using them. It'll show you the binary number system base 2. The class turns bits on and off by turning the cards face up, face down. We're going to do that part of the exercise on our activity guide, but I don't think we really need to use the cards themselves. You're going to observe the numbers that result from these different patterns. Eventually, the pattern is extended to a generic 4-bit system. In our activity guide, we're even going to get farther than that. So go ahead and pull up your activity guide, and it should look like this. Okay. So the first part of your activity guide, binary number cards. Okay, you can see the number cards, they're the dice, and I'll give you a quick look at it right here. This is what I sent you. This is the cards themselves. What I do in class is we cut all of these out. Each person would get, or each group would get, a set of 4 numbers, and that's the dice numbers. Now you can go ahead and cut them out if you choose and use them in that respect, but I think you can do it just by looking at them. Okay, so the first part of our activity guide, binary number cards. Work with your partner, and in this case, you're working by yourself, because if you're watching the video, it means that we are not together. Okay, so work with your group to figure out which cards should be face up or face down to get the correct number of dots. Put a U under a card that should be face up and a D under the card that should be face down. The first one has been done for you. Now, before we get started, there's one thing I want to tell you. Okay, if you look at these numbers here, this is a 4-bit binary number system. 4 dots, or 4 sets, 4 boxes, in other words. We always start from the right-hand side, and I will go over this over and over again as we get into this lesson today. We always start from the right-hand side. Binary numbers start from the right-hand side, and we start the same number. It always starts with the number 1, not 0, but the number 1. Now, as we move to the left And this is for, again, we start on the farthest right-hand side. We start with 1. Then we double that, we go to 2. We double that, we go to 4. We double that, we go to 8. And if it was a 5-bit number system, the next box would be what? If you said 16, you are correct. 16, you are the winner. 16 would be the next number. And then it continues on infinity. So then this next number would be 32. Next number would be 64, and so on. Doubling this first number, always going up, or doubling it up as you move up one block. So again, we start off with 1. We go to 2. Double that, we go to 4. Double that, we go to 8. Okay, so this part of the activity guide, we're only dealing with a 4-bit number system. So let's look at the numbers. And if we were trying to find a 5, go ahead and spend a couple seconds trying to figure out what the 5 would be, which one would be up, and which ones would be down. So I'll give you seconds. Go ahead and take about 10 seconds to do that. I'm back. That should have taken you a little more than 10 seconds, but here's how it works. Okay, so the letter 5. We know that 4 plus 1 equals 5. So do we want to use the 8? No, we make that a down. So we put a D there. We want the 4, so let's make that a U. We don't want the 2, so we make that a down. And we want the 1, so we make that an up. So there it is. You've just completed the 4-digit or a 4-bit number block for the number 5. Now we're going to do it for the number 10. So go ahead and take a couple seconds and go ahead and do that. Again, I like to only give you a couple seconds, right? For me, it's a couple seconds, but I know it's probably a little bit more for you because you are turning on and turning off the video as you need your time. So, okay, next one we're dealing with the number 10. So what do we got? We got 8 here, and we always start with the biggest number we have. So 8 would be the biggest one in this 4-box digit workbox. So we have 8 plus 2 is 10. So we're going to go make that an up. We're going to make that a down. We're going to make that an up because that adds up to 10, and that leaves that with a down. Okay? So now we're telling our computer we want this one on, this one off, this one on, and this one off. So we're telling our computers on, off, on, off. On for 8, off for 4, on for 2, off for 1, giving us 10. Okay, so now we go on to 2, and let's do 2 together. Do we want the 8? No, we're going to make that a down. So I make that down. Do we want the 4? No, we don't need that, so we make that a down. It becomes a downer. Okay, little joke. 2, yeah, we want that one because that's it. Put that one up. Do we want the 1? No, we don't need that either. So that's why we've done it. We've just done a 4-bit boxes for coming up with numbers. Okay, so now here it is. What's the lowest number you can make? Look on here. What's the lowest number we can make? Did you say 1? You are wrong. It's 0. We can make a 0. By putting all of these down, we get a 0. So the lowest number we can make is a 0. Whoops. It's a 0. There we go. Try that again. Okay, what's the highest number we can make? In this set of boxes, what's the highest number we can make? We have 8 plus 4 is 12. Plus 2 is what? 14. Plus 1 is 15. So the highest number we can make is 15. So we write down 15. 1, 5. There it is. Okay, so now let's go down to the next one. Okay, using the pattern. You may use the same pattern even without the cards. Okay, shade over the cards you do not want to use to make your number. The first one has been done for you. Okay, so we want 7. So here it is. 4 plus 2 is 6 plus 1 is 7. Okay, so go ahead and do the remaining boxes here. I'll give you a couple minutes and I'll come back to you. Okay, welcome back. So let's start with the 3. We're going to shade out the ones that we don't want. So 3 here is a 2 and a 1, right? So let's shade out that one. Let's see. Let's go with shade out that one. We shade out that one. And there we go. So now we have a 2 and a 1. I just put letters in here, so it's my way of shading it out. Makes it a little easier. Okay, now let's look at 12. We have 8 plus 4 is 12. We want to keep those two, so we shade out this one. And we shade out this one. Okay. And then we look over at 6. 4 plus 2 is 6. Any other combinations? No, we only have the 2. 4, so we shade out the 8. And we shade out the 1. That gives us our 6. Okay, so that's fairly easy. Now, let's look at this one. You can use the same pattern without dots, without the dots. Answer the questions by shading in the boxes below. Okay, we always know that this box is what? Number 1. This box is 2. This box is 4. And this box is 8. So we know that all these are the same. So by using this combination, we first of all look at this insect. How many legs does this insect have? This insect has 6 legs. So we need to get a 6. So a 6 is what? A 4 and a 2. Well, if you look up here, you can always see that too. So we're going to only put in, we're going to shade out this box. And we're going to shade out this box. And that gives us here, you can actually put the number in if you'd like. You can put a 2 and a 4. And that lets you know what they are. Rather than using dots, we've used the 2 and the 4. So let's go down here. What grade are you in? Okay, you guys can go ahead and answer that. Most of you should be in 8th grade. So we want an 8. So we would put in the 8 here. And then we X out these. Dun, dun, and dun. Okay. How many sisters and brothers do you have? That's up to you guys. Each individual is going to be a little different. So each number is going to be different. So let's say if you had 5 brothers and sisters. So let's go with a 4 and a 1. So we would X out the first one. 4 we keep. X out the third one. And keep this last number 1. Okay. 4 plus 1 is 5. And that's just what I said. Okay, so make up a question. So you can make up any question you want. Go ahead and do that on your own. Okay, let's go down here. Using the online widget to help you answer the following questions, all right? This is a 5-bit widget, okay? Remember, we started from this side. Here's the 1. Here's the 2. Here's the 4. Here's the 8. What's the next number going to be? If you said 16, you are correct. So on this 5-bit widget, that number would be 16. Okay. Remember, doubling up each time. Start with 1, double that to 2, double that to 4, double that to 8, double that to 16. And if we were to continue on, we'd go to 32, 64, 128, and so on. Okay, so let's go on to the next one. How would you make 16? Okay, so we know we're starting here with 16, right? So we just type in 16 there. And then we'd X out that one. We'd X out this one. We would X out this one. And we'd X out that one because all we need is a 1 box of 16. Okay, take a couple minutes to do the last 2, and I'll come back to you. Okay, we're back. 27. So we want to start with what? We want to start with, we know we're going to probably use 16. And then we have 8, right? 16, 8 is 24, 25, 26, 27. So that's what we're going to do. So we'll go with 16, because we always start with the bigger box first. 16, we need the 8. That's an 8. So we went 1, 2, 4, 8, 16. Do we need the 4? No, because that would already put us too high. 16 and 4 is 20. That beats up 28. So we're going to X out that one. And we will go with a 2 and a 1. Okay, so we went 1, 2, left out the 4, kept the 8, kept the 16, gives us 27. Okay, let's look at 31. 31, we're going to keep the biggest. So we keep 16. We want the next one, the 8. Yeah, we always want to keep the next one too. 8 is 24. Now we need to get how many more? 7 more. So guess what? 4, 5, 6, 7. We're going to keep them all. So we go with 4. We go with 2. And we go with 1. All that adds up to 31. Okay, so you did that. Now that was a 5-bit widget. Okay, now we're going to go to 6-bit widget. In a 6-bit widget system, what's the biggest number that you can make? The biggest number. So go ahead and try that and see what you come up with. Remember, 6 bits. Here's 5. What's this next number going to be? 32. Okay, if it's 32, you're going to add up all of these numbers to see what it comes up to. I'll give you a couple minutes. Finish. Okay, if you came up with 63, you are correct. Okay, 6-bit widgets gives us a total of 63 points, or 63, and we'll call them points. It's an easier way to address it. Okay, the record for most skips by a dog and person in 1 minute is 59. How would you encode 59? So to do 59, what are we going to do? Let's start with the biggest first. Our biggest is what? 32, because we're in a 6-bit. Remember, 1, 2, 4, 8, 16, 32. Okay, we're getting up to 59, so let's go to the next one too. Let's add those two up. So 32 and 16 is what? 48, and we need 11 more. So do we want to use the 4? Probably, or I mean the 8? Probably, so let's try that. Put in the 8, and that gives us 40, 56, so now we need 3 more, 2 and a 1. So let's X out the 4, we don't need that. And we keep the 2, and we keep the 1. Okay, 32 plus 16 is 48, plus 8 is 56, 57, 58, 59, and that's what we were looking for. Okay, decoding multiple numbers. What's the most people are lifted up and thrown in 2 minutes? These are all you're going to have to look up. So I want you to go online and spend a few minutes looking these up and then writing down what the numbers are for each one. We're going to be using them probably, I believe, in code.org. So go ahead and look those up yourself after we get done here, and write down the numbers for what you come up with. Reflection. What is the most important? Why is it important to have a set bit length for your numbers when you send information in a binary? Okay, there's a couple different things that you need to remember. If you don't know the bit length of each number, then you can't tell where each number starts and stops. So it could be different numbers depending on where you start and where you stop reading each number. In other words, we can see that right here in this. If we don't know how many bits these are, we're not going to be able to use the numbers here. If we know that we're looking for number 59 and we only have a 5-bit number, are we going to be able to do it? No, you can't do it because there's not enough code in here to come up with 59. So you have to make sure that you have enough bits to cover your number. Using the 8-bit binary system to send a question and a binary answer to a classmate. Okay, you can do that on your own. Give it to your parents and see if they understand what you're talking about. Okay, so now what I want you to do is go over to code.org. So let's sneak into code.org and go to bubble number 2, and we will start there. Okay, so we're in Unit 5, Lesson 5, bubble number 2. Bubble number 1 was just the overview, and we've already read that twice. I read it to you twice. If you didn't catch on, I'm pretty good about sneaking a couple things in there I want you to remember. So, okay, so first of all, 5-bit number. I would have one of you read this normally in class, but I can't hear you read it, so I will read it to you. When you only had 4 bits, the highest number that you could make was 15. Now, you'll have a chance to work with more bits to make higher numbers. In this activity, the dots are replaced with numbers, but you still add up everything that's showing to see what number the binary code stands for. The least most bit doesn't have a number yet, so you'll have to give it one. Okay, so we're going to do this. Click on the bits to turn them on and off and see the different numbers that you can make. We don't have a partner, so we're going to click edit to change the values and so on. So, okay, what we're doing is we're going to go ahead and run it. Okay, go ahead and click on each one. So we have a 1. We'll start from the left again because we always start from the left. A 2, a 4. What's the next number? 8. And what's the last number? 16. So we'll go 16. We click 16. Let's see, change the value of the leftmost box. We put a 16 in there and save the new value. And there you go. So that's what your first portion will look like. Again, we've already gone over this. This is more or less, the activity guide's kind of a prelude for what we're going into with code.org. And I kind of like the way that leads into it because it makes your code.org exercises a little bit easier. Okay, so we know that. So we are moving on to the next one. So let's go to bubble number 2. We're finished with that. Or bubble number 3, excuse me. Continue on. And bubble number 3, 6-bit number. The widget helps you calculate 6-bit binary numbers. Do this with your partner, and you don't have a partner. Answer the following questions. What's the biggest number you can make with this widget? The record of most skips by a dog and person in 1 minute is 59. How would you encode binary 59? So let's run it. We've already kind of done it. It's like I said, this is a repeat. So we start off with the biggest number this time, 32. Then we add 16 to it. We have 48. So we need what? 11 more. If we did the 8, that would probably give us, 56. Now we need 3 more. So we skip the 4, put the 3 in, and put the 1 in. We've already done this, so I'm going to run over it kind of quickly. And that's how we fill in our widget in the boxes with numbers only. Okay. So remember, we start from the left. 1, 2, 4, 8, 16, and 32. And what would be the next number after that if we went to a 7-bit? 64. You are right. You win the prize. Okay, let's move on to the next one. Okay, so we are now in bubble number 4. Okay, decoding multiple numbers. Here's a widget that can calculate 4, 5, and 6 bytes. You can use it to find two world records encoded in the binary string below. Okay, the most number of people lifted and thrown in 2 minutes using a 4-bit. Okay, so if we go ahead and run it, here it is, 4 bits. Okay, so the first one, most number of people lifted and thrown in 2 minutes. Okay, so the answer for that one was 12. If you look through that right, and if you found it in your Google search, you would have found 12. So we need to find 12. So again, we start with 8. We move to 4. Oh, what does that equal? 12. That's all we need. Whoops, a little less of there. Okay, so let's move on to the next one. Most canned drinks opened by a parrot in 1 minute, 6 bits. We're using not the 5-bit, we're using the 6-bit. You always have to tell us how many bits your numbers are going to have, because that will make a difference. Okay, so we're using the 6-bit widget down here. So the answer to that question was 44. Hopefully you found 44. So we want to find that number. So we start with 32. And if we put 16 in it, what do we have? 48. That's too much. So let's get rid of that one. So we go to the 8. That gives us 40. And 44 is what we're looking for. So let's just give it the 4. We leave everything else dark. And that's it. We just decoded these 2 bits. A 4-bit and a 6-bit. Okay. All right. We're finished with that portion. Let's move on to the next. Bubble number 5. Decoding multiple numbers. Okay. Decoding multiple numbers. Here's a widget that can calculate numbers up to 8 bits. You can use it to find the values of 2 world records below. Don't forget to make sure that the 1 bit is always on the right, farthest most right. We know that. If you have extra bits on the other side of the widget, just keep them turned off. Okay, so here we go. Let's go ahead and run it. Okay, so the first thing, longest tail on a dog in inches, 5 bits. Okay, longest tail on a dog was 30 inches, right? Okay, everybody should have gotten 30. Okay, so we want to find 30. So let's start with, we're doing a 5 bits. So 1, 2, 3, 4, 5, 30 inches. So we start with this one. Oops, we start with this one. 1, 2, 3, 4, 5. So we'll start with 16. We go to 28, which is 24. Another 8, or excuse me, another 4, which gives us 28. And we want to get to 30, which gives us the 2. Okay, here's a 5-bit widget. We're not using these, we're leaving those blank. 1, 2, 3, 4, 5, and we're keeping these dark too. This one dark too, gives us 30. Okay, and then we look at most spoons balanced on someone's face, 5 bits. Okay, so let's reset that. Now we go to 5 bits. Here we go, 1, 2, 3, 4, 5. So we're going to start with this number. By the way, what was the answer to that? It was 31. All right, so we look at 16 again, because we always start with the farthest one up. to the left, another one, farthest one on the left. 16. 8's 24. 4 more, 28. And we want to get what, 31? 30 plus 1. And there it is. In a 5-bit widget, 1, 2, 3, 4, 5, we found the number 31 for the most spoons balanced in someone's face. Okay. And that's how the computer would read it, just from this bit of information. Okay. All right, let's move on to the next one. So bubble number 6. Okay, bubble number 6. Here's a new bit string. This time, you don't know the bit length of the two numbers. Try to decode the numbers without knowing the bit length. Okay, so here we go. Largest wind chime in feet. Okay, so if we're looking at the largest wind chime in feet, what was that? It was 42 feet. So we're going to try and figure out which one we want to start with. 42, we know that 1, 2, 3, 4, 5, 6, 7, a 7-bit widget would put us at 64. That's too much. Our number again is 42. So let's start with the 6-bit widget. There's 32, and we want to get 10 more. So we want to go with the 8 and the 2, and that gives us 42. So we've found out that the number of bits is 1, 2, 3, 4, 5, 6. So we're using a 6-bit widget to find the answer to the largest wind chime in feet, which was 42 feet. Okay, let's reset it. And we'll do it for the furthest arrow shot in someone's feet. Oh, with someone's feet. I'm sorry, shot in someone's feet. That wouldn't work very well, would it? Furthest arrow shot with someone's foot in feet. Okay, first of all, number of bits. What was the answer you got for that? It should have been 20. Okay, so if you got 20, we're going to go back here. Now we want to go 1, 2, 3, 4, 5. 5 starts us out at 16. That's a good place to start, because if we went to the next one, it would be 32, and that's too much. So 8 we want to leave. We use a 4. There it is, 20. And that's it. So on a 1, 2, 3, 4, 5, that would be a 5-bit widget. Okay. So that kind of gives you an idea. You can use it you can find how many bits the widget has without knowing how many bits you have, just by counting down the highest number that you think might come close to the number you're looking for. Okay. All right, let's move on to the next one. Okay, and number 7. Okay, if you don't know how many bits long each number is, you won't be able to decode a string of numbers. For example, the following binary string can be decoded many different ways. If you split the string like this, the string reads 10 and 84. So what it's doing is telling you, here's a long bit. Okay, now you're dividing this up into a 1, 2, 3, 4, 5, 6, 7-bit and 4-bit. Okay, here it's 11 bits. So 7 and 4, you can come up with the numbers 10 and 84 for the highest. If you split the string like this, okay, so we'd have a 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. You come up with 42 and 20. And let's take a look at this. The way you do that is looking at the darks. These are looks like the offs. 1, 2, 3, 4, 5. So we go 1, 2, 4, 8, 16. Okay, here's 16 plus 4 is 20. And that gives us this one. Let's look at this one. We're not using the 1. We're using the 2. Not using the 4. We're using the 8. So that's 10. And then we're using not 16, but 32. 10 plus 32 equals 42. Okay, I hope you all understand that. Okay, so that's breaking them up into 2 different widgets. That's breaking up an 11-bit widget into a 2, 4, 5, and a 6-bit widget. To solve the problem, people agree on a fixed length for every number. The following strings have the same 2 numbers, but each number takes up exactly 8 bits, no matter how many bits it actually needs. Okay, so do this. Use the binary widget that uses 8 numbers. Okay, so here we go. Up here. Okay, click on the bits to turn them on and off. Okay, so let's find out. Check your answer. Check the binary widget to decode the string uses 8 bits. Okay, so if we do 8 bits, we go 1, 2, 4. Let's count the way. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now we're looking at, and we're just looking at, it's really for our own reference purposes. We're looking at an 8-bit widget. That's 8 bits, okay? So if we were to use an 8-bit widget, the highest number is 128. You can add them all up. They add up to 255. So that would be telling our computer that we're going to use an 8-bit widget, and we're trying to get the number 255. Now, if we didn't want the number 255, we were trying to get 247, we would block out our 8. Same idea is what we've been doing, but you have 8 bits to deal with. Okay, let's turn it back on. Gives us a total of 255. Okay, does that make sense to everybody? I hope it does. This is a huge bit widget. But like I said, when you're explaining it to a computer for a number, you can go on way up line to whatever number you need to get, and that's how a computer would read it. So let's go on to the next one, last bubble. Okay. Oh, I guess last bubble is a video. So go ahead and watch the video, and you will be done with that. And thank you for joining us here today. And I look forward to seeing you in lesson 6. So be sure and watch the video, because the video will give you answer some questions that you might have. All right, thank you very much, and we'll talk to you later on. Okay, I had a chance to look at that video. That video explains everything that we went through, kind of gives you an overview of how it works and what it entails using the binary number system. I hope you all enjoyed it, and I hope you got something out of it. It's nice to be able to know how to encode and decode numbers now in our binary number system. So thank you all. I look forward to seeing you in lesson 6.